Hi friends, welcome back. We're going to talk about congruency in triangles today with angle, side, angle. And so if we have two triangles that look like this, sorry, I should have drawn these out first. And this angle is congruent to this angle, and this angle is congruent to this angle. The side in between those two angles must be the one that's also congruent. So this would be angle, side, angle, angle, side, angle. Okay, let's talk about a proof that uses this angle, side, angle. All right, looking at this guy right here, let me scooch that down just a little bit so you can see it. All right, so looking at this guy right here, we are told that JK is parallel to LM, and we indicate that by using little arrows. So JK, LM, so those guys are parallel. Then we know JL is parallel to KM as well, so these guys are parallel. Okay, so here is what we know. In a previous video, we talked about proofs. I said, here's a little cheat sheet, kind of a guideline on how to do these proofs. If you haven't already, you may want to write that down. So we do our givens, and then we're going to do some definitions, and then our obvious but not givens. So our first is our given. Those guys are parallel. Now, definitions, things like midpoint, bisector, I don't see any of those words there, so we're going to skip that, and we're going to go to our obvious but not givens, and I see two. The first is that we have parallel lines here, which means we have angle relationships. What I mean by that is we have this guy is going to be congruent to this guy, and this one is going to be congruent to this little dude right over there. So the reason being is because these lines are parallel, they are cut by this transversal here. So what we say is, for number two, we're going to say, okay, JKL, angle JKL is congruent to MLK. MLK, I want to make sure I'm capturing these correctly. So that is because they are alternate interior angles. And actually, that's the same reason why the other angles would be as well. So we can say angle MKL. MKL is congruent to JLK. JLK. And that is because alternate, I can't spell and talk at the same time apparently, alternate interior angles are congruent. Fantastic. Okay, I see another obvious but not given here, and that is that if I were to separate out these two triangles, KL would be congruent to LK, right? You can always go back and look if there's a congruency statement that you're working to try and prove. You see how it's KL and then LK. So we want to make sure we put those in the correct order. So for number three, we have KL is congruent to LK because of the reflexive property. So at this point, I've done my obvious but not givens, and my next reflexive property, and my next part is to see, maybe are these congruent based on side, 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 angle, side. And sure enough, if you take a look at these triangles, we have angle, side, angle in the triangle, and then angle, side, angle in the other triangle. So these guys are congruent, and it is triangle JKL is congruent to MLK because of angle, side, angle. Excellent work. We will see you next time.